Assalamu alaikum. Dear students, my name is Arshad Siddiqui and I am assistant professor in the Department of Mechanical Engineering and Technology. I am assigned to teach you the course Fluid Mechanics 1. The course code is ME204. I welcome you all in first online lecture of Fluid Mechanics 1. Prior to discuss some other thing, I would like to give you a brief introduction about myself. I completed my bachelor's degree from NAD University of Engineering and Technology in 1996, and then I completed my master's degree from Concordia University, Montreal, Canada in 2008. More than 20 years I served in industry, in building construction engineering, or in building construction industry. I worked both with contractors and consultants and big groups and big industrial groups as well. My job was to design and execute building services systems such as HVAC system, plumbing system, firefighting system, irrigation system, fuel distribution system, etc. I worked on different positions, and finally I leave the industry as MAP engineers. After that, I joined NAD University in 2017. I hope you will be benefited with my vast experience and professional working knowledge. Now, in case of any queries, if you are in the university, because we are available in university 5 days a week, okay, my contacting hours in the morning from 10 o'clock to 11 o'clock, I am always available. As it is mentioned in the slide, I have an office in room number 2 in the mechanical engineering department. My extension is 2631. Other than that, if you have any queries related to administrative issues or the course issues, for the administrative issues, already your class advisor, Mr. Munir, has already created a WhatsApp group, and we all are registered in that. So if you have any administrative issues and official issues, you can contact with him anytime. For the course related issues, I advise your CR to create a WhatsApp group where you can put your queries related to the course, and I will answer to your CR as soon as possible to all your queries. Now I am going to switch off the video so that we can focus on the slide and the lecture what I'm going to start now. So before going into detail of the course, we need to know why this course is important, why it is added in your curriculum, what are the objective of the course, what we want from this course. So here are the two basic objectives as it mentioned in the slide: to impart theoretical knowledge of fluid statics and dynamics, and to enable the students to analyze and solve engineering problems. The first objective of the course are to teach the basic principles of fluid mechanics, to develop students' ability to analyze the fundamental and applied aspects of fluid flow problems. Because this is an applied course, and further to develop the students' ability to apply basic principles of fluid mechanics, mathematical concepts, experimental data, and engineering judgment to specific problems. The second objective of this course is to design to provide a strong foundation for the related subjects to be taught in the later part of the bachelor programs. That means this course leads to a large number of connected courses such as the Fluid Mechanics 2, the Heat and Mass Transfer, Vehicle Dynamics, Vehicle Design, Combustion, Emission and Propulsion, and Automotive Power Plants, etc. So there are so many courses where this course will provide you a foundation for the courses. Now the next slide is basically showing you the education system that we are practicing in our university. So to understand the OBE system, we have 5 keywords: objective, outcomes, assessment, performance, criteria, and evaluation. But here I want to discuss with you about CLOs. So basically the CLOs are mapped with 11 PLOs, and these 11 PLOs are mapped with 4 PEOs. So what is PEOs? As it is mentioned in the slide, the PEOs are a statement that graduates are expected, the statements or the attributes that graduates are expected to accomplish during first few years after graduation. The PLOs, the statements that students are expected to accomplish during at the time of graduations. So to achieve those PLOs, we made CLOs of the course, because the CLOs are course based, PLOs are program based. So what are the CLOs of the course? So we have made 4 CLOs of this course, because this course has 3 credit hours. So we have 3 CLOs for the theory and 1 CLO for the lab. The 3 CLOs are basically focusing your cognitive domain, and the 4th CLO is focusing on your psychomotor domain. So first CLO is connected with PLO1, and CLO2 and CLO3 are mapped with PLO2. So what are the CLOs? The CLO means the course learning objective. So what exactly we want to achieve from this course? Okay. So the CLO1 is basically to be able to define or describe different theoretical terminologies and concepts used in fluid statics and dynamics. The CLO2, that to be able to apply pertinent equation of fluid mechanics and solve different engineering problems based on fluid statics and dynamics. So here we will solve all the applied problems, the practical problems of fluid mechanics that we experience in our daily life. In CLO3, to be able to analyze and solve dimensional analysis problem, and here we will use different dimension analysis tools to solve the fluid mechanics problem that we will learn also in this CLOs. Now we are going to jump on the course content. So what are the topics we are going to study in the course? So now let's look at the course content. This course content is basically divided into three parts: the fluid statics, fluid dynamics, and dimension analysis. Fluid statics in fluid statics we will study what is the fluid and what are the fluid properties and what are the type of fluids existent in nature. So we will study the different type of fluids in this topic. After the complete understanding of fluid and fluid properties, we will discuss about the fluid static, because we have combined the basic introduction and the fluid statics topics in the under the heading of fluid statics. So after the complete understanding of the fluid and fluid properties and the type of the fluids, we will talk about the fluid statics. In fluid statics, we know the meaning of statics means fluid at rest. Here we will study the fluid at rest. In fluid at rest, in fluid statics, we will see what are the type of forces acting when the fluid is at rest. The major force that acts when the fluid is at rest is pressure force. Then we will see that how we measure these forces by using different instruments like manometers, gauges, etc. So here discuss about the type of hydrostatic surfaces like the flat surface, the curved surface, and the solid body motion. So we will also study that how the forces are acting on those surfaces and where these forces are acting, what is the position where these forces are acting, and how we can calculate the magnitude of force and the position of the force. We will also study the buoyancy and flotation, so standard atmosphere. After complete understanding of fluid statics, we will study the fluid dynamics. Basically, in the fluid dynamics, we have combined the topic of fluid kinematics and fluid dynamics. So, what is kinematics? In kinematics, in fluid kinematics, we study the motion bus. Here we discuss about the motion related parameters like acceleration, velocity, and displacement disregarding of force. Here we will discuss only the effect of, in fluid kinematics we discuss only the effect of force. And what are the effect of force? The effect of force are displacement, velocity, and acceleration. According to the first law of Newton, if we want to move a body, then you have to apply a force to work against the inertia of the body. If there is no force, then inertia will not allow body to change its displacement, velocity and acceleration. Here we will study two different approach, that Eulerian approach and Lagrangian approach. Also we will study the type of lines like path lines, straight lines, timelines, streamlines, etc. After the fluid dynamics, after the fluid kinematics, we have also the fluid dynamics topic. In the fluid dynamics, the study of motion, the fluid dynamics is the study of motion which deals with force and effect of force. So here we consider the force and effect of force like displacement, velocity and acceleration. So fluid dynamics is basically indicates the energy available in the fluid. Okay, so due to fluid energy we develop or we derive some equations like Eulerian's equation we will study in the fluid dynamics, Bernoulli equation we will study in the fluid dynamics, and continuity equation, and also the impulse momentum theorem. So you have seen in your daily life when we watering the grass on the ground, so there is a sprinkler which is connected with a pipe. So when we turn on the water hits the sprinkler and sprinkler start rotating and sprinkle the water to the grass. So this is basically a study of the impulse of momentum that then there is an important topic, that is a fluid flow. Okay, in the fluid flow this is a very important topic, especially from the practical point of view, that we can also observe in our daily life. So what are the important topics that we are going to study under the fluid dynamics in the fluid flow? We will study the ideal flow and also the viscous flow theory. Boundary layer theory is an important aspect of a viscous flow. Then we will study the drag and lift. So what is drag and what is lift? When we drive a bike or car, we face a force against the direction of motion. That force is basically known as drag force. When the fish swims in water, against the flow of water, the water exerts a force on the fish. That force is basically a drag force. That means the fish has to swim against the drag force. And what is the lift? Lift we can understand in a way like a man falling through a parachute. When a man falls down using a parachute, he doesn't fall suddenly. He fall to the ground in a controlled manner only because of this lift force, because this lift force help him to go down slowly. Then we will study the pipe flow, the piping network and the pipe bends. That we can see we have overhead tank in our house, and then there is a piping network which is distributed throughout the throughout our house, in the bathroom, in the kitchen, all the accessories are connected with the pipe, and these 2 points are joined with the straight pipes, with the bend of pipes and different valve and accessories. Okay, that we will study in this chapter. Then we will also study the open channel flow. Open channel flow is basically it is a flow open to the atmosphere. Okay, and finally we will study the dimension analysis. In the dimension analysis, we will study the technique to solve the fluid flow problem, and the technique we will going to learn is called the Buckingham pi theorem, and also we will study the similitudes. So here is the brief introduction about the content of your course. Now move on to the next slide. So here you can see I have a recommendation for your handbook. So your handbook is Fundamental of Fluid Mechanics by Munson, Young and Okishi, 6th edition. So this will be your handbook. So handbook supposed to be a book which covers most of your course content and also explains the concept in easy way with good examples and applied problems. So here you can find number of numericals to practice all your concepts. Now the next slide is indicating the CLO assessment mechanism, that how we will assess this course. So the marks breakdown. So this is basically a 100 marks course. So I distributed in a way that the midterm is a 20 marks. Okay, in the midterm I will cover the question from CLO1 and CLO2, and then I will give you assignment of 15 marks. Okay, it will be equally distributed, almost 30 questions, 10 questions from CLO1, 10 questions from CLO2 and 10 questions from CLO3. Then we will conduct a quiz of 5 marks. In this quiz we will cover only, I will give you 1 question from CLO3. And then final exam, and the final exam, in the final exam the questions distributed in a way that 30% from CLO1, 40% CLO2 and 30% of the question related to CLO3. So this is how the 100% marks will be distributed. When and how we will take these midterms, assignment and quiz, that I will explain to you in my future lecture. Now we are going to discuss the basic introduction and basic concepts. The basic terms or basic concepts which are associated with fluid mechanics. The fluid mechanics itself is made of fluid and plus mechanics. So in a general term or in the basic definition, what is fluid? So we can say that any substance which can flow is called fluid. This is a very basic understanding that we all know the definition of fluid. Fluid may be liquid or it may be gas. The second part is mechanics. Mechanics is a science or part of science which deals with force and its effect. If force and the effect of force due to applied forces, we know the effect produces by a force is change in shape or size. It can deform and it can bring change in a state of motion. What does it mean of a state of motion? A state of motion of a body or a particle can be defined by displacement, velocity and acceleration. What basically a force does, if a body is in rest, it brings into motion, and if a body is in motion, the force brings into rest. The study of such behavior of force is called mechanics. So, where we apply the concept of mechanics on fluid means effect of force on fluid when discussed in detail. So when we apply the concept of mechanics on fluid means effect of force on fluids when discussed in detail, then a subject come into existence is called the fluid mechanics. Fluid mechanics is classified, fluid mechanics is a classical subject. Okay, this subject is in existence long before human civilization. We know Pascal's law, Archimedes' law. These are a very old laws. So this subject is developing since long. Now the basic study of fluid has been very broad and advanced, and now we have many new branches of fluid mechanics such as compressible fluid dynamics, hydrodynamics and hydraulics, gas dynamics, aerodynamics and metrology. So what is basically the hydrodynamics? And now we are going to see the terminologies that we have seen one by one. The fluid mechanics, as I discussed in detail, now we can see the fluid dynamics. Okay. So fluid mechanics, the science that deals with the behavior of fluid at rest or in motion and the interaction of fluids with solids and other fluid at the boundaries. Okay, so fluid dynamics is a fluid mechanics is also referred to as fluid dynamics by considering fluid at rest as a special case of motion with zero velocity. Okay. The fluid mechanics is basically referred to both fluid static and fluid dynamics. Okay, but fluid mechanics, if you are considering zero velocity, So then we have a hydrodynamics, the study of the motion of fluids that can be approximated as incompressible, such as liquid, especially water and gas at low speeds. So in the hydrodynamics case, basically we focus on the pipe flow, because in this case we will consider the fluid is incompressible. Technically the fluid is not 100% incompressible. It is slightly compressible by changing its temperature and pressure. And the other category is hydraulics. These are very also a well-known fields in the automotive industry. It is also very useful, especially we used in heavy vehicles this technology successfully. A subcategory of hydrodynamics, which deals with the liquid flows in pipes and open channels. Then gas dynamics. This gas dynamics deals with the flow of fluid that undergoes significant density change, such as the flow of gas through a nozzle at the high speed. Okay, so in the gas dynamics, we can give an example for the gas dynamics, like the turbine, the nozzle injecting the steam through to the turbine, and surrounding a high speed aircraft, air surrounding a high speed aircraft, aerodynamics, and others, so on. So there are many important branches of fluid mechanics that are advancing with the time. Now let's move on to the slide. Now let's move on to the slide. Now we are going to see the fluids and the type of fluids, and how the fluids and solids are different in details. So basically, what is a fluid? So fluid is basically, definitely it is a matter. So the matter exists in three basic forms, or two principal forms. So what are the three basic forms? That is solid, liquid, and gas. So basically the liquid and gas has the almost the identical properties or the identical characteristics. So that's why we combined them together and we made another word that is called a fluid. So whenever we say fluid, that means liquid and gas. So the matter reduced to two principal forms, that is solid and fluid. So here we can say, what is a fluid? Fluid, a substance in the liquid or gas phase. Liquid and gas has same characteristics. How it has the same characteristics? Because the both liquid and gas has no definite shapes, where the solid has a definite shape. So that means the fluids, it has no definite shape of its own, but conform to the shape of the containing vessel. So whatever is the size and whatever is the shape of the container, it takes the same shape. So now we are going to see how the fluid is different from solid. Okay, how we differentiate the fluid with the solid in little more detail. A solid can resist an applied shear stress by deforming. Okay, the solid can resist an applied shear stress. So what is a shear stress? Shear stress is basically So what is the shear stress? A shear stress is created whenever a tangential force acts on a surface. As it is mentioned here, the force is tangential to the top surface. Okay, the force, we know that the force per unit area is equal to stress. So this stress is called shear stress, which is parallel to the top surface of the object. So consider we have a two flat plate in which we have an object deformed. We have an object that is rubber. So the bottom plate is fixed and the upper plate is movable. So when we applied a force on the upper surface, now we are talking about the solid. Okay. In case of the solid, when we applied a shear stress on the top surface, so the body doesn't deform unless the applied shear force is greater than the inertia force of the solid. When the applied shear force is greater than the inertia force, then the body starts deforming. Okay, and it resists the force due to deformation. This deformation is called shear strain. This deformation is called strain. So in the solid, we can see as you increase the shear force, the deformation will increase, and the time will come the deformation stops. It will not deform continuously, but it deforms the strain produces in the body in a particular manner that we can describe in the form of a Hooke's law. So for the solid, the Hooke's law can make a relationship between the stress and strain. Now we can see how the fluid behaves when we apply a shear force on the fluid. Then how the fluid react? Does it react same like the solid, or it behaves differently? So now consider the same. We have a bottom plate and we have a top plate. So now we applied a shear force on the top of the surface of the fluid. So what happens? What we observe? We see the fluid deforms continuously under the influence of a shear stress. Okay? That means if there is a shear stress, the fluid deforms continuously. If there is no shear stress, there is no deformation. The fluid stops. Okay, but if there is a shear stress, no matter how small is the shear stress, in the solid we know if there is a small shear stress, it is less than the inertia of the solid, the body will not deform. Okay, the body will resist. Okay, till the shear force overcome. But in solid, even a small shear stress will allow fluids to deform, and it will deform continuously till there is a shear force. So this is the difference we observe. Now what else we observe? What else are the difference we observed between solid and liquid? In solid, stress is proportional to strain. That means we can apply a Hooke's law. Okay, but in fluid, stress is not proportional to strain. Okay, because this strain is not constant. This is deforming continuously. It deforming continuously with a particular rate. So in the fluid, the stress or the applied shear stress is proportional to the rate of shear strain. Now, what else are the difference? When a constant shear force is applied, a solid eventually stop deforming at some fixed strain angle, okay? Because after a certain point, the solid doesn't deform, it stops. There is a break-even point and then there is a breaking point comes. But in the case of solid, there is whereas a fluid never stops deforming and approaches a constant rate of strain, okay? In the third point, we can see at the bottom, the fluid never stops deforming and approaches a constant rate of strain. So this is all about the fluid and the fluid. Here we can see some application areas of fluid mechanics. This is a metallic heart, okay, which is made of a different fluids. This is a natural flow and weathers. There's a lot of fluid energy that we can see. The waterfalls, it's bringing a lot of energy, the fluid flow, and the ship moving on the water. And there is a exhaust chimneys that we can see. The hot airs are exhausting through the chimneys, and there is a hot air flow, the exhaust of the hot air flow that we can observe. The ship moving on the water that we can observe, the boats, okay, the flowing on the water, it's using a water energy also. The aircrafts, the wind energy, it is also an example of the lift. There's a human body, how the water is how we can sense the flow of blood by using the technology. There is a car. Now there's aerodynamic design of the different cars. There is a wind turbines using a wind energy, and there is a piping and plumbing system, which are basically a good example of a pipe flow. Industrial applications, we are using other than waters and different fluids flow that we are using. So this is the first plane that the Wright brothers built it, and this is a wind turbine. Then in examples, this is the oldest wind turbine that we can see, that is basically used to drag water or produce electricity. Now we are going to discuss the importance of dimensions and units that we have already studied in our metric levels and intermediate level, but here just we are going to give you a quick review and just to recall them all, because this is very important to be remembered. So the dimension and units. So what is basically the dimension? Any physical quantity can be characterized by dimensions. Okay? If you don't know the dimensions, so it doesn't matter. It is how we can say it is 1 meter, or it is 1 kilogram, or it is what. Okay? So any physical quantity can be characterized by dimensions. Okay? The magnitude assigned to the dimensions are called units. Okay? If you don't know it, so it's going to be useless. Okay? If you don't know the value, so if you don't know the units, so you cannot tell the apple is how many kilogram. We cannot call it 1 meter apple. We cannot say that. So if you don't know the unit, so it is very hard to explain the physical quantities. ठीक है. So some basic dimensions such as mass, length, time and temperature are selected as a primary or fundamental dimensions. Okay, so we have a fundamental dimensions and we have a secondary dimensions. The fundamental dimensions are the mass, length, time and temperature are called the fundamental dimensions, while others such as velocity, energy, volume are expressed in terms of a primary dimensions and are called secondary dimension or derived dimensions, because these dimensions can be derived by using the primary dimensions. Okay, because volume can be explained as length cube. Okay, so volume can be expressed as length cube. So in the same way, the velocity can be described in the form of basic or fundamental dimensions, like what is the unit of velocity? Meter per second. So meter is basically a length, or second is basically a time. So L over T, or L T minus 1 is basically the derived dimension of velocity. So now we are using a different system of units to describe the units: the metric or SI system or the English system. The SI system, a simple and logical system based on a decimal relationship between the various unit. English system, it has no apparent systematic numerical base, and various units in this system are related to each other, rather arbitrary. So here some SI and English units are mentioned. Okay, 1 feet is equals to how many meters? There is a unit conversion that you have to know. Okay, and also we can derive unit by using different equation or different standard mathematical relationships. Okay, if you know the mass and acceleration, you can calculate the force. Okay, here you all can see, here we can see the different aspects of units, as it is indicating in the picture on the moon, because wherever you go, the mass never vanish. Mass is always there. Okay, so mass wherever go, it never it cannot be created, it cannot be destroyed. So wherever, whether it is Earth or whether it is the moon, the mass is always there. Here in the second slide, the man with the apple, it's showing you the conversion. Okay, it is a complete balance. So 1 Newton force and 1 pound force. Okay, so here the 1 apple of this much gram is equal to 4 apple. Here is also showing the unit conversion in the SI system. The gravitational acceleration is equal to this. In the English system, the gravitational acceleration is 32.174, is indicating the values. Here is basically just giving you a practical understanding of 1 kilojoule. Okay, what is the 1 kilojoule quantity? A typical match yields whenever it is burned. Okay, when it is completely burned, it gives you a 1 kilojoule energy. Okay, so this is how you can conceive the amount of energy that we use. So now the dimensional homogeneity, how important is the dimensional dimensional homogeneity. Dimensional homogeneity. Okay, so this is we can see how important is the dimensional homogeneity. All equation must be dimensionally homogeneous. That means if you will not eat properly in the picture as it is shown, if you will not eat properly, what will happen? Your stomach will hurt you. So eat properly in a proper way. So in the same way, the all unit what you are using in the equation, okay, so whether it is left hand side and right hand side, it must be homogeneous. ठीक है ना? It doesn't seem that there is the equation, some of the value you are using in SI system and some of the units you are using in English system, and then solve the equation, so definitely it will give you a surprise. Okay, so that means all the values you are using on left hand side and right hand side equation must be homogeneous. So unity conversion ratio, all non-primary units, secondary units can be formed by combination of primary units. Force unit, for example, can be expressed as, the force is basically Newton kilogram meter per second square. In the English system, the pound force is equal to the gravitational acceleration taken into 1. So this is how the unit must be balanced, must be homogeneous. Okay, they can also be expressed more conveniently as unity conversion ratio. Okay, so you can convert them also from one unit to another unit, but it must be homogeneous. It should not be like this, this is kilogram is pound and this is meter per second square and you will get 1 Newton. No, it's going to be wrong. The unity conversion ratio are identically equal to 1 and are unitless, and thus such ratio or their inverse can be inserted conveniently into any calculation to properly convert units. So here also showing an example of converging units. So all units you see here, it is in from SI system to English system, okay, and this is all showing the same. So every unit conversion ratio as well as its inverse is exactly equal to 1. Okay. So now we are just going to recall some of the fluid properties that we have already studied properly probably in thermodynamics. You have studied in your first year. So let's see. So the properties of fluid. So here we are going to see what is the property. Any characteristics of a system. Some familiar properties are pressure, temperature, volume and mass. Okay, properties are considered to be either intensive or extensive. So we know there are two types of properties, intensive properties or extensive properties. So what is the intensive properties? Intensive properties are those that are independent of the mass of a system, such as temperature, pressure and density. It means doesn't matter whether it's small or big. Okay, the intensive property never change. Okay, so extensive properties, what is extensive properties? Those whose values depend on the size or extent of the system. So to observe that what are the properties are extensive properties and intensive properties, we have a container as it is mentioned on the top box, that is mass, volume, temperature, pressure and density are mentioned. And now we divided the top box into two halves. So now we are going to observe if we divide the box or container into two halves, how the properties are changes. So if we divide the box, we can see the here we can see the extensive properties which are depending on the mass is divided into two halves, that is half of the mass, definitely the mass divided into two half, so half mass is this side and half mass is the other side. In the same way, the volume is also an extensive property. It is also reduced. The half volume is this side and half volume is this side. So that means the mass and volumes are the extensive properties, but the temperature and the pressure and the density remains same, because whatever is the temperature on this side, we have a same temperature on the other side. Whatever is the pressure we have on this side and the same pressure we have on the other side. So whatever is the density of the fluid we have this side, the same density we have this side. So this is the way we can say the fluid, the temperature, pressure and density is the intensive property, which is independent of mass, and the properties which are depending on the mass are called extensive properties. Expressive properties, extensive properties per unit mass. Okay, if you divide the property, if the divide the magnitude of the property with the value of mass, so you will get the specific properties.